Hello everyone, my name is Neeraj Parmar. I am from Ujjain, Madhya Pradesh, pursuing Bachelor of Technology in Civil Engineering at ITS in Bengal. So here I am going to present you determinants and its properties in my today's lecture. So let me start with. We will cover these points including the definition, how we denote the determinant, some of its terminologies, what is minor and cofactor, and finally the evaluation of the determinant. So let me start with definition. Determinant is nothing but the array of numbers which are denoted in between two specific lines in a squared manner. So this is how we denote it. Let's suppose we have the numbers A, B, C, D, and this is a 2 by 2 determinant. So it can be of any order. Let's say A1, A2, A3, B1, B2, B3, C1, C2, C3. Here we have another determinant of 3 by 3 order. So completing with the definition and the denotation, now come to some terminologies. So we have some terms including column, row, what is order, then what is diagonal entries, and here we go with. So the elements that are coincide in one row, we call them as row elements. Similarly with the column elements, so as the name suggests, the order of this determinant is nothing but 3 by 3. We denote it as 3 into 3. This 3 into 3 does not mean the order is 9. The order we will actually say is it as only 3. We can directly call it as order of 3. Now the diagonal entries, so the elements come on the place of AII. It means the jth element and ith element having I equal to j, the elements that comes in that place, we call them as diagonal elements. This is A11, A22, A33, these are the diagonal elements here. Okay. So completing with this, let's come on to our next topic, that is what is minor and cofactor. Let me first erase this. So what is minor and what is cofactor of a determinant? So let's say we have this determinant of 3 by 3 with elements as this. So minor and cofactor are determined with using a row or taking any column or row as base. Suppose let's say we are going to take row 1, R1 denoted as this as our base. So calculating the minor using this row, the minor of A1 element, or we can say the minor of the element A11. It is nothing but the minor will be the smaller determinant of this. So we will exclude all the row elements and all the column elements, and after that what we left with, we will calculate the determinant of that thing also. So this is B2, B3, C2, C3. So this is our minor of the element A1. Similarly, we can calculate the minor using any of the elements. So let's suppose we can calculate it using the element A23. So the minor will be A1, 3, A3, C1. There is little difference between minor and cofactor. That is, minor is nothing but the matrix. So minor is nothing but the smaller determinant. What the cofactor is, we denote the cofactor at Cij is equal to minus 1 to the power I plus j minor of ij. As you can clearly see, there is no more difference. Let's say we have to calculate the cofactor of this C11. Since minus 1 to the power 1 plus 1 will be 2, so it will be 1. So the cofactor of C11 will nothing but, so the cofactor C11 will nothing but the same as the minor of A11. But as we come to the cofactor of element 1, 2, that is C12, it will be minus time the minor of the element A12. Hope you have understood these terms. Now finally we will calculate how we can determine the value of the determinant. Hope you have cleared about this and you have no doubt what we have learned. So let me tell you how we calculate the value of determinant. Suppose we have these elements. This is how we basically denote it. So that's why I am using these terms. We can denote it, the elements in place of this. Anything we have to use. So let's say I want to calculate the determinant value using this row. So what is its determinant will be nothing but A1 times the minor of A1 A2 times minor of A2 actually it is not the minor, we have to actually put the cofactor here. So as the name suggests and you all are aware now, the only thing I have to do is putting a minus sign in front of the element that have a negative cofactor. So here minus 1 to the power 1 plus 2. So cofactor will be, as you can see, negative, minus, plus, plus. This is nothing but the delta and we denote it as the determinant. Hope you have cleared this. So let me conclude how we denote it as delta as our determinant value. It is equal to Aij delta of order n by n. Okay. So coming on to the next part, we will go with the properties. So here we have 8 properties today. Hope you are clear from now. Onwards we are going to our next topic, that is the properties of determinants. So first property is, if we interchange the rows and columns of determinants, if rows and columns are interchanged, then the value will remain same. And the value of the delta will remain same. Second property is, if any row elements or any column elements, that all the values of the one row or one column, if they are 0, then the whole value of the delta will be 0. Suppose let's say first row having all the elements 0, then what we can conclude that the value of the delta will be 0. Similarly, third property we have is if two of the rows they are similar and means every elements of them are equal, then we can say that the both the value of the delta will be 0. What I am going to say is, if say let's say row 1 is equal to row 1 elements are equal to row 2 elements, then the value of delta will be 0. Next property is we can take out any factor from the from any row or any column of the determinant. That is, if this is our determinant, we can also write it as k times hope you have cleared this. Next property we have is that if we interchange any row or any two rows or any two columns, that is if we interchange R1 and R2, let's say, then the value of delta will become negative. This is one property. Hope you have clear from. Now onwards, the sixth property is going on to the next property. Let's say if we multiply the row elements by a new row and add it to that row, then the value of that delta will be same. What I am going to say is that let's say I am adding a multiple of a row to another row. Suppose R1, R2, R3, this is my delta. I am converting it to the new delta, that is R1. I am changing R2 and R3 and R1 and keeping it same. So R2 I am writing it as R2 plus adding 3 times the row R1, and in R3 I am adding 5 times R1, 2 times R2. Let's say R1. Then both will delta will be equal. How I am going to say this? Let me show you. Since, okay, let me conclude one more property, then you will clear about this. What does the seventh property says that if one of the row elements are multiple of another row elements, then the value of the delta will be 0. R1, 2, R1, R3. If this is our determinant, then the value of this will be 0. And the last property I have to say is that, okay, so the last property is that we can break the determinant into two subdeterminants of same order with respect to any row or any column. What I am going to say is that suppose this is our row 1, row 2, row 3, and this is our determinant. So we can also write it as R1 dash, R2, R3, R1 double dash. So I have broken it into two parts with respect to the row 1. So I want to explain you this property again, how we have written this. since we can also write it as, suppose this is the property we have to prove. We can also write it as using this property, the eighth property, R1, R2, R3 plus R1, 3R1, R3. Since this is our delta again, now going on to this, since we can also take this element or take this factor out of this determinant, so this will become as 3 times delta, that is nothing but R1, R2, R3, and in place of R2 we have R1 and here we have R3. So as we have concluded in one of our properties that if two of the row elements are same, then the delta is equal. So again we have delta is equal to delta. Hope I have covered all the properties and you have learned all this. So let me summarize what we have learned today. Our topic was determinant and its properties. We have concluded its definition, how we denote it, and some terminologies including minor, factor, cofactor, and rows, columns. After then we have seen that how we calculate the determinant. Then finally we have seen 8 of its properties. What are they? First we have seen that if we interchange the rows and columns of a determinant, then the value of the determinant will be unchanged. Second, we have seen that if one of the row elements or one of the column elements, all the values of them are if 0, then the value of the determinant will be 0. Third one we have seen is that if two rows have similar two rows or two columns have similar values in them, then the value of the determinant will be 0. Fourth property we have seen that we can take out any factor from the determinant from any row or any column. Fifth one we have seen is that the determinant will remain unchanged if we add the multiple of a row to another. Okay, so these are our 5 properties. The next one is if we interchange two rows, then the value of determinant will become negative. Also, we have seen that if any row is a multiple of another row or any column is multiple of another column, then the value of determinant will be 0. And the last property we have seen is that we can break a determinant into two different determinants of same order. Hope you have cleared all of these terminologies I have used today. Thank you. Okay, since I have told you this all, let me give you some examples if you can solve this. I hope all of you have wrote what I have taught in today's class. My first question is, okay, tell me, who is going to solve this first? Thank you for what I have taught to you.